this is for year 11 methods. We're going to look at exercise 5D, question 3L. So we're asked to find the implied domain and the corresponding range for the functions defined by the rule y equals 1 on 2x plus 1 plus 3 plus 2. So this is an example of a hyperbola. Okay, so we know the basic shape of hyperbola looks something like this. We have asymptotes on x equals 0 and y equals 0. So first of all, we need to find where the asymptotes are, and I can't say the asymptotes at x equals 1 because there's a 2 here. Okay, so with these questions we have to rearrange it. Well, we have to take the factor out so that the left-right shift is clear. So this is 2x minus a half plus 2. So now I know, when I draw the graph, I know that the asymptote will be at x equals a half because the graph has shifted half units to the right and 2 units up. So it's going to look like that. Okay, and I draw the graph, it's going to look roughly like this. Okay, it may not be completely correct, but we're just finding domain range, so it doesn't matter. Okay, so in terms of domain, what values can x take? Well, you can see the graph goes, it's approaching this line, but it's going forever to approach this line. So it's going to the negative infinity to a half. It doesn't quite reach a half, it's approaching it. And then it starts close to a half, not touching it, and then going to positive infinity. So essentially, what you can write for the overall domain is the real number line, the whole number line, excluding a half, because it cannot physically touch a half. Okay? For the range, something similar. Okay, can you see that it goes from positive infinity to 2, but not including 2, and then not including 2 to negative infinity. So it's essentially the whole number line except 2. Okay. So the idea behind implied domains is just what domain does the graph naturally take up. Okay, so in this case, the domain and range, or the domain it naturally takes up is reals excluding a half, and the range is reals excluding 2. So we'll move on to question 6 now. The graph is shown of relation. It's a relation because it fails the vertical line test, right? Now I want to highlight that all functions are relations. They're also relations, but not all relations are functions. So it's like the relationship is the functions are here, and the relations is the bigger set. So functions are a subset of relations. So all graphs are relations, but not all graphs are functions, because in order to be a function, you need to pass the vertical line test. Okay, so we've got sideways parabola, and it's given by this rule. Okay, form two functions with the domain and specify the range of each. Okay, so the rule is y squared equals minus x plus 2. If I were to square root both sides, I can plus or minus x plus 2. Okay, so what do we want to do? We want to, from this relation, form two functions with the domain and specify the range. So we can form, well, what I've essentially done is this y squared equation represents the combined graph of these two, because there's essentially two pieces. We've got the top piece, which is, if I rearrange this to show what the left right is, because there's a negative in front of the x, I can take the negative out and you'll get essentially x minus 2. So we can see that the graph has been moved 2 to the right. Okay, so the graph of root x has been moved 2 to the right, and there's been a reflection. Okay, so the graph of root x has been reflected, so 1 reflected and moved 2 to the right. Okay, so we've got two versions. We've got the plus version and we've got the minus version. Okay, this is going to be the one that looks like this this is going to be the plus version, okay? And the one that's going to look like that is the minus version. So essentially what it's asking you is to form two functions with that domain. So I can write the first function as f such that, well, the first graph is going to look like this, okay? So you're going to write it as f, it goes from negative infinity, so you always have to write the domain to specify the function, negative infinity to 2, I'll include 2, go into reals, and you go f of x, you need to write the rule, equals the positive version, so root negative x minus 2. The second function, I'll call it g, would be, it'll look like this. Okay, so go, that's a negative version, so again the domain's the same, because you're going from negative infinity to 2, to reals, and g of x would equal negative minus x minus 2. Okay, and the answers might have expanded that to have the same equation as this. Okay, but the reason why I factorize it is just so I can get a visual of what it actually looks like. Okay, so essentially these are functions. Why are they functions? Because they're essentially one-to-one, or they pass the vertical line test. Okay, they happen to be one-to-one functions, but they both pass the vertical line test, so they're functions. So I've just split the whole graph into two pieces, up and down. Okay, because I know the equations what the up and down are. It's just plus or minus root of negative x plus 2. So hopefully that helps. I know it's a bit confusing, but if you look into it more carefully, you can break relations like these down into two separate functions.